Okay, so we looked at trig power integrations when the sine function had an odd power, and we looked at it when the cosine function had an odd power. And it was a little bit of work, but it wasn't too bad. So now we're going to talk about what if both the sine and cosine powers are even. And this is not a fun one, but what we're going to do is we're going to rewrite both as squares raised to a power. So my example here is I have sine to the 4th times cosine to the 6th. So I wrote this as sine squared for the 4th power and cosine squared cubed for the 6th power. So I wrote both of those as something squared raised to a power. Now, I'm not going to use the Pythagorean theorem here. I'm going to use what is called double angle identities, and they're written differently in different places. So the way I have them written here seems to be the way that works best for me. But one of the identities is you can change sine squared into 1/2 minus 1/2 cosine of 2x. So notice that changed the sine squared into some relationship of cosine 2x. So it doubled the angle. That's very important there. So the angle was x, and now it's 2x. Okay? And likewise, there's a cosine squared identity that transforms into 1/2 plus 1/2 cosine 2x. Both of these go to cosine. Okay? Notice there's a difference in the SIGN, the positive and negative between them. One of them's positive, one of them's negative. So in this case, we're converting a square function into a function that's not square, but it has changed the angle. And usually after doing so, you're probably got a good chance of reverting back to something that's going to use one of the odd powers earlier. Okay, this is one of the longer ones. So I have a couple of examples here. So let's see. The first one, sine squared of 3x times cosine squared of 3x dx. So that's what I'm trying to integrate. So both of these are even powers. And you'll see if I do another example that the larger this power, the harder it is. With the odd powers, it didn't really matter how big it was because you pulled one out and you fixed it. But with these even powers, it's kind of a rough thing. And I see I've got COX there where it should be cosine. Okay, but we're going to change both of these. So they're already squares to a power, so they're to the first. So we're going to have the integral of, let me use a different color for it. I'm going to change the sine squared of 3x to, and it's down here, 1/2 minus 1/2 cosine. And right now the angle is 3x, so I've got to double that to 6x. So the angle that was in there got doubled. Okay, so let me use a different color here that might help you identify that. So it was 3x in the formula I'm given, but in my identity it's just x, and then when you move over it gets doubled. Okay, and the same thing is going to happen with the cosine. So the square is no longer there, but the cosine squared will turn into 1/2 plus 1/2 cosine of 6x. There we go. So let me highlight those as well. So the 6x is the double angle, just like the 3x was the normal angle. So whatever angle you have to the square power is going to be doubled when you reduce that power. Now the bad part here is we're going to have to fold that out. So let me see if I can do that as I move it. So I've got a binomial 1/2 minus 1/2 something times 1/2 plus 1/2 something. So let's see, that's going to be the integral of FOIL. 1/2 times 1/2 is 1/4. 1/2 times 1/2 cosine of 6x. I'll just go ahead and write it. So that'll be plus 1/4 cosine of 6x. That's the outer, but the inner is negative 1/4 cosine of 6x. So those are going to cancel out, but the last is going to be plus 1/4 cosine squared of 6x. So now that we've got it copied, let's move over. Dx. And as I said, we can knock out those two middle terms. We really create a difference of squares, but that's, well, not a difference of squares here, or did I? It should be negative, shouldn't it? Yes, it should be negative 1/4 cosine squared. So let's fix that. Good to catch that before we get too far. So just to rewrite this again, we have 1/4 minus 1/4 cosine squared of 6x dx. Now, you have to ask yourself, what do I do now? Okay, so we have cosine squared. We can't use a u substitution because if we let u be the cosine, there's no sine on the outside. So really, this comes right back to what we were doing already. M and n are both even. There's no sine, so the sine is 0. So there's just no sine present, so there's nothing you can really change with that. But the cosine here is squared. So we're going to use the same cosine identity formula again. So let's see. It'll be the integral of 1/4 minus 1/4. And then we need to start taking care of this other thing. So we got cosine squared of 6x. That's going to turn into 1/2 plus 1/2 cosine, and we got double that angle, so now it's up to 12x dx. So we used that same formula again. Now the nice thing is we're about done with it. It's just not much fun. So let's see. Let's do some distributing and cleaning up here. I've got the integral of 1/4 minus 1/8 minus 1/8 cosine of 12x dx. I'm going to do one more. Combining 1/4 minus 1/8 is 1/8 minus 1/8 cosine of 12x dx. So, what do we need here? Well, the integral of 1/8 is 1/8 x. And then when we go to integrate this negative 1/8 cosine, let's just write the negative 1/8 here. And let's do a u substitution. For the cosine, u equals 12x. du equals 12 dx. So 1/12 du equals dx. So we can change this to u inside and we'll get a 1/12 out front. So let's see here. That'll be times, the 1/8 will be times 1/12. And the integral of cosine is sine. And that'll be of u, which was 12x. And that'll be a, wait, I don't need that integral sign out front. So sorry about that. Then there'll be a plus c at the end. Now that's definitely not in the prettiest form. So let's clean it up just a little bit here. So we should have 1/8 x minus 1 over, I believe that's 96 sine of 12x plus c. So I'm going to check my answer. If it's a small mistake, I'll come back and correct it and talk to you about it. If not, we will, if I don't come back, you'll know it was right.